All right, tell me the first 5 terms in the sequence given by this explicit formula where any number n in the sequence is just n factorial plus n. I'll give you 3 minutes.
Quiz on Friday.
Yeah.
What's wrong with you?
What's wrong with you?
We like just started this
Yeah.
like yesterday, right?
Wait, what? Oh, that's a good point. What am I telling?
Didn't we?
That's not you. That's AP calculus.
Oh,
You're pre-calculus. You just have
okay.
8.123.
It's because maybe it was erased.
Oh, sure, that's why.
Yeah,
Yeah, let me fix that.
that's why I was like, what? Slow down.
I'm slowing it down.
How was yesterday?
Eric.
Ain't no monk says or. Isn't that illegal to drive that? That was what you was not.
Ah. Okay. What is the first term in the sequence? It is 2, because we want to do, hold on. A sub 1 would be 1 factorial plus 1. What's 1 factorial? Plus 1 is 2. What is the second number in the sequence? Well, that'd be 2 factorial plus 2, or 2 times 1 plus 2, which is 4. What is the third number in the sequence? That'd be 3 factorial plus 3, or 3 times 2 times 1 plus 3, which is 6 plus 3 is 9. By the way, this is, I should have said this. This is one of the guided practice. I think it's the next one on the sheet that we didn't do. Fourth number would be 4 factorial plus 4, which is 4 times 3 times 2 times 1 plus 4, which is 16. And then A5 will be 5 factorial plus 5. So it'd be 5 times 4 times 3 times 2 times 1 plus 5, which is 65. Is that right?
What? This is not what it said.
No?
No.
What's 5 factorial? Is it 60? Is it 120? Who said 60? It is 120. 125. I was just making sure you were paying attention there. I put that in to see. 4 factorial? You think that's wrong too? Who said it was 16? Alright. Yeah, because it's 6 times 4 is 24, not 12. I agree with that. I agree. All right. Questions about these? Do we feel okay with exclamation marks? Aren't those fun? Okay. Does anyone need more time to write? We're going to finish out the lecture for 8.1 today, which is these. Using factorial notation, we'll do one more thing. Summation notation, that's pretty cool. Sums of infinite series, and then just applying it. All right. One more guided practice. Tell me what 8 factorial divided by 2 times 6 factorial is. 3 minutes. First person to get this answer gets all of the mustard in Wisconsin.
Wait, how did you say you do on the calculator?
It's math. Then you go to PRB, which is the 4th column. You have to go to the right 3 times. And then it's option 4, exclamation. But you don't need a calculator to do this one. That's weird. Does it really say that? That's weird. You might have typed something in wrong. What you got?
How was I supposed to know?
But you don't need a calculator to do this one.
Why not?
You can do this in your head.
I probably can.
Did you fix it, Tristan, or is it?
I just did it yesterday.
Yeah, I might just put the number in there.
Ah,
Actually, you gotta put in a number.
Wait, I bet I know why.
you don't, yeah, you don't need a calculator to do this.
No, well, you don't.
You don't either. Well, I mean, I guess you need to know what 8 times 7 is. If you know that, then you don't need a calculator. All right, I think, well, we don't need 2 more. It looks like most people like that. You ready? Okay, so this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. You see where I'm going with this? 8 times 7 divided by 2. 56 divided by 2. 28. Isn't that wild? Look at that. You see that? You show this off at parties and you're going to be the life of it. You will have to like beat people away because they'll be trying to get a conversation with you.
Oh, are they gonna do that?
They will.
They're gonna be like, wow, you're a nerd. Where'd you learn that, Mr. Wade?
No, they won't say that. All right, anybody need more time to write? Okay. So what is this?
That's crazy stuff. Duh. Whoa, that's nonsense.
That is n. Right? If you make this an easier problem, you'll see this really quick. What is 5 factorial divided by 5 minus 1? 4 factorial.
Oh.
That's 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, right? Cancel, cancel equals 5. So 8 factorial divided by 7 factorial is 8. 10 factorial divided by 6 factorial would be 10 times 9 times 8 times 7. And then all the rest of it will cancel out, right? You see how this works? You want to do another? Sure. Let's do 3 factorial.
Question.
What?
How do you know what it is?
It's just for this one, you're just simplifying.
So you just use your random number?
I did, yeah, to demonstrate why this works, pick, and this is something you should do on the ACT too. If it's messing you up that this is ed, make it something else. Make it 5 or 4 and see if you can find out what the rule is. If we make ed 5 factorial divided by 5 minus 1 or 4 is just 5, right? 8 factorial divided by 7 factorial is just 8. Because all you do is you cancel out the bottom factorial with any of the ones that start at 6 and go beyond, and you leave the rest multiplied together, which in this case is just 5. In this case would be 10, 9, 8, 7. In this case would be 3 and 2. Yay? Well, let's see if it's really yay. Does anyone need more time to write? Are you sure? Positive? You try this one then. What is that? Wah, ha, 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 ha. Oh, who was the first person to get right the other guy in practice? That I owe a bunch of mustard. Trent, I have a bunch of mustard coming your way.
From Wisconsin.
From Wisconsin. Hopefully you got warehouse historian. Because it's a lot of mustard. I like this math because it wrinkles my brain. When I first learned it, I was like, whoa, this is some crazy stuff happening right now. Yeah. This is my favorite lesson just because of the notation. I love the notation for factorials and for summation and how the operators work. So just be 4. And then you can eliminate this. 4, and then that one. You might try writing it out. Write it out. N plus 1 factorial is n plus 1 times n minus 1 times n minus 2 times n minus 2. And try writing out the other one too. Yes, so.
I got it.
N minus 1 times n minus 2 times n
Well,
minus
we said he had done it. No. Oh. Ah. Well, like this is accident.
Okay. Now try doing it with instead of ending 1, try doing it with ending 2.
Right.
And then try ending 3. And see if you can come up with that. You there is an easy. You can't do it.
Because it's the same thing. Pneumonia. How are you gonna take one out there? Where are they going? Well, it's like.
You
these
can't
are different numbers,
quite
right?
fully
These
cancel
are
it out.
different. So like, I think it would be the same.
They're not. They're going to fuck.
You just have that. And I didn't get placed back.
Let me write it out. It helps if you're struggling, try writing it out. If at any time you're not sure how they simplify, expand them and then you'll see. So let's expand this. This is 4 times 3 times 2 times 1 over 3 times 2 times 1. Okay, so then what cancels out over here? Well, 3 times 2 times 1 and 3 times 2 times 1, right? So that simplifies to just be 4. Now, I imagine what most people are struggling is this n business, right? Well, again, if you're struggling, expand it out. This is n plus 1 times n minus 1 times n minus 2 times n minus 3, and so on and so forth, right? Until you get down to 0, right? Or until you get down to 1, sorry, until you get down to 1, right? You just keep decreasing it till you get to 1. All right, let's expand the denominator. So this is n minus 1 times n minus 2 times n minus 3. Again, we keep decreasing by 1 until we get to 0. Okay, now look what cancels out. And then the only thing left is an n plus 1 and n. Those are the only two numbers that are bigger than n minus 1. N minus 4 would be in this list, right? This would be n minus 4.
Oh.
And then n minus 5, 6, 7, 8, right? Until you get down to 1.
Yeah, that's kind of like.
Well, if n was like 100, right? Then it'd be n minus 1 is 99, n minus 2 is 98, n minus 3 is 97. No, you keep going until you get to 1. Until you get to 1. So in this case, if n is 100, we would keep writing parentheses till we got to n minus 99. Because 100 minus 99 is 1. So I don't actually know if I could expand it out as far as I did. This is actually only true for n greater than or equal to 2. Yeah. Because you start at your number, n plus 1, and then you keep decreasing it by 1 and multiplying it. So right, you do 10, 9, 8, 7, 6, 5, 4, 3, 2. So I do n plus 1, then subtract 1 from that, gives you n. Subtract 1, n minus 1. Subtract 1, n minus 2.
So it doesn't matter how far you go?
For simplifying, it doesn't, no. Because we're just looking at the rule of what would happen. But if this wrinkles your brain, choose a value for n to make this easier. And just make n 100. N plus 1 factorial over n minus 1 factorial. If we let n equal 100, then that would be 101 factorial over 99 factorial, which would be 101 times 100 times 99 times 98 times 97 times 96. And in the bottom, you have 99 times 98 times 97. So that this cancels with that. So we're left with just 100 and 101. 100 and 101. And then if you go back and rewrite this in terms of n, if n is 100, then that's just n. And if n is 100, that would be n plus 1. And then there's your two terms that go right there. Yay or absolutely not, Mr. Lake? Eh? Does anyone need more time to write this? Well, let's try it. Let's do it. Let's try this. 6 factorial divided by 3 factorial. What's that? Six times 5 times 4. Okay, now let's try this. What would that be? N plus 3, N plus 2, N plus 1. Trenton? I'm gonna give some of that mustard to Noelia and Brianna. Okay? Hopefully you have a warehouse. Again, Wisconsin has a lot of mustard in it. Does anyone, no one's gonna dispute me on that. We all agree. Yeah. That's easy peasy.
Some would argue that.
No.
Kansas has a lot of-
Mustard? Okay.
He said-
All right. Do we enjoy this? Are we okay with this? Do you want to see some more? I can do these all day. Don't test. I'll do these. Okay, let's take a little break. Okay. Oh, why is the light on? The light's been on this whole time.
That's foolish.
There you go. There's a patient for you.
I like that.
I don't know if I like this one
Why
because
is it like a forest and a mountain?
no, I don't actually know what you mean. Yeah.
Sides,
Yeah,
and then there's a mountain in the back.
yeah.
Because that just seems wrong.
You don't like that?
I think
It should all be mountains or all forest? Is that what you mean?
It's just wrong.
All right.
What is wrong with mountain? No, it's.
You like that?
I mean, yeah, sometimes. But it's like a snowy mountain. I mean, it's like a snowy mountain.
Okay, don't look at this one yet. That's gonna be a brain break for later, okay?
At the peak, not the whole thing.
All right, you ready for that? This is the math they put up on college classrooms. If you watch any of those like movies that pretend to have any math in it, they'll write a bunch of nonsense on the green board, right? In chalk. It always has one of these on there somewhere, even if it has nothing to do with the lesson. This is just what math, smart math looks like. But today, you'll be able to read this and know that that makes no sense how they're using it. They're just putting up nonsense. What this is a summation of a sequence. How you read this is you start with your I. That's your index of summation, tells you what number in the sequence to start with. So this is your starting number. You will take that number and do your rule. And you will add up all of the numbers in the sequence until you get to your ending number right here. So in this case, you take the first number in the sequence, add to the second, third, fourth, until you get to the number, in this case, they said n, the nth number in the sequence.
Yeah, wait, is the ending number like the actual number or like a block?
It could be an actual number. Usually it's an actual number. It could be n. It could be or it could be infinity.
Okay, but like, they don't like A5 was like the ending number and equal 120.
Uh-huh.
120 go there or 5?
If you're doing to the 120th number in the sequence?
Oh, so far.
I don't know, actually. Do you want to see an example? Yeah. Okay, so this is just how to read this. This is your starting number, ending number rule. Let me show you an example. So for example, let's find this. So this tells me I'm going to start at the first number in the sequence, and I will add till I get to the 5th number in the sequence. So, and I will take each of those numbers, in this case, 1, 2, 3, 4, and 5, and I will plug them in to the rule, in this case, 3i. So if we plug in 1 to the rule, we would have 3 times 1, and then I will add that to the next number, 3 times 2, plus 3 times 3, plus 3 times 4, plus 3 times 5. And then we stop at 5 because that's where it told me to end. And then calculator. Do we need a calculator for that? Yeah, sure. 3 plus 6 plus 9 plus 12 plus 15 is 45. Okay, so for the next, does that make sense how we did that? Okay, so for the next one, we're going to start at 3 and we were going to stop at 6. So first number I'm going to plug in is 3. So I'll do 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared. Calculator. 1 plus 9 plus 1 plus 16 plus 1 plus 25 plus 1 plus 36 is 90. All right, and so for this one, we'd start at 0 and we would end at 8. So we're going to do 1 over 0 factorial. What is 0 factorial? 1. So 1 over 1 plus 1 over 1 factorial. What's 1 factorial? Hey, it's also 1. Isn't that weird? Plus 1 over 2 factorial, which is 2. Plus 1 over 3 factorial, which is 6. Plus 1 over 4 factorial, which is 24, not 12. Plus 1 over 5 factorial, which is 120, not 60. Plus 1 over 6 factorial, which is 720. Plus 1 over 7 factorial, which is something. 5040 plus 1 over 8 factorial, which is 40,320. You know what? I don't want to do it either. So you know what we're going to learn how to do instead of doing that by hand? Let's do it on a calculator. But I have to clear the screen in order to do that. So I will not do that yet. If you do not have a TI-84, you should grab a TI-84 really quick. Because you'll need it. Huh. Oh, is this Euler's number? I think this is E. Is this E? This is Euler's number. Oh, isn't that cool? I'll show you what I'm talking about. This is E. Isn't that crazy? I wasn't even ready for that. Okay, you want to see how to do it on a calculator? Okay, stop share. Calculator.
I mean, I'm trying to. I'm having.
You-
I
you
just
sh-
wanna know how to put it in the calculator.
Let me show you how to put it in a calculator. You want to see how to put this in a calculator? Let me show you how to put this in a calculator. Okay. Hold on. Do you want to see how to put this in the calculator?
Yeah.
Let me show you how to put this in the calculator. Okay, let me show you. All right. So you're gonna hit math. Is that right? Yes, math 0. And then it'll ask you for the letter, but whatever letter they tell you to do, it's always just X. So and then we said to start at 0 and at 8. And then they wanted a fraction. So math, no, wait. Is it math? No, number, fraction. 1 over X factorial. So that's math. Probability, option 4. Enter. And look, if you do second E, if you have some of your calculators will not look like that, in which case you want to grab another one. No, you don't want to. Math, 0. You don't have it. You'll need to grab a different TI-84. There's a few TI-84s that have their OS old and unupdatable for some reason. Math, right to the number, and then hit up. Oop, hit up. Should be the last option, D, numerator over denominator. We'll write it like a fraction. I mean, you could do division in this case too, but if you want something that looks like a fraction. And look, do you see that? I bet you if we made this number not 8, but infinity, these numbers would be exactly the same because that's Euler's number. 2.718281828. They are very close. If we didn't stop at 8 but went to infinity, they would match. Isn't that great? That was shocking. I wasn't ready for that. Okay, let's see if you really know how to do this. Try this one. You can do it by hand and then check it with a calculator.
Or I can do it with a calculator.
Excuse me,
Excuse you.
do it by hand first, then check it with a calculator, okay?
That's what I do. I just on my calculator playing it.
Okay. For those of you watching the recording, all of them have pencils in their hand. None of them have a calculator. They're all doing it by hand, so you should do it by hand too.
Imagine the people like when they listen to these recordings, what is in their head? Like, it's so chaotic.
No.
I got the answer, Mr. Lake. By hand.
Yeah, I'm sure most of them who watch this just skip and just look at the handwriting.
Answers, yeah, I would do that too.
Yeah. Let's fast forward through all this. I could ask. I'll ask Bethany what she thinks when she listens to these. And Laurel. Laurel and Bethany.
No, I can guarantee you Laurel doesn't watch this.
No, I'm pretty sure she just does the homework.
Like skips, like, puts the wrong answer twice and then gets the answer. No, she doesn't do that. She doesn't? That's when you're like, girl, I don't know how to do that. I was like, give me the answers.
I mean, no, I don't think she does that because her test scores are pretty good. Unless, I don't know.
I'm gonna go up to her and I'll be like, Mr. Lake said you fail on your calculations.
Yeah.
No, she can bring up, but she has to come back, so she can. That's true, she doesn't even fit. Right, like, guys, what up, what up, what up?
Math,
Oh,
0.
yeah, go to math. And right now to 0, and it's summation.
Math, 0. If yours, when you hit math 0, tells you not a crazy E, then your calculator is in the wrong version. And you'll need to grab a different one. All right, hopefully you got that this is start at 1, end at 4. So it's 4 times 1 plus 1 times, or sorry, plus. You put times there. Plus 4 times 2 plus 1 plus 4 times 3 plus 1 plus 4 times 4 plus 1. And if you add those all together, what do you get? 44. Isn't that great? What's more fun than this kind of math? Let me get out of here. Maybe matrices. Matrices are fun. Add, subtract, multiply, matrices. See, and look at this. It looks so complicated, but now that you know how to read this, this is actually like, this is adding and multiplying, right? It is really not as complicated as it looks. Okay, so here are some fancy rules that you could, or properties or shortcuts that you could use if you're finding the sum of a constant n number of times. The result would just be the constant times that number, n. If you have a rule that is being multiplied by a constant, then you can move the constant in front of the summation and just multiply it at the end, right? Because every factor would have that constant, and you can just factor it out, add them all up, and then multiply by the constant. You could just multiply it at the end and not even type it in. So if you were doing the summation of like 2x, right? And instead of plugging in 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4, you could just do 1 plus 2 plus 3 plus 4 plus 5 to whatever, and then at the end multiply by 2. You could just move that 2 to the front. Yeah. The summation of two different rules, AI and B sub I, is the same thing as the summation of AI plus the summation of BI. That makes sense, right? And same thing with subtraction. If you have two rules, A sub I minus B sub I, you could just find the sum of each rule individually and then subtract the results. This is not as important today as it is back then. Back then, when you didn't have a calculator, if you could simplify it before you do the summation, since you had to do it by hand, that was super valuable. Nowadays, we could do the summation of x or 2x in the same amount of time, so it doesn't really matter. Yay? Yeah. But back in the day, that's a really big deal. If you wanted to be a calculator for NASA, you had to know these shortcuts. I just heard, if you didn't catch that on the recording, everyone in this class just said how that was their dream job. And they're upset that you can't do that anymore. All right, so a series can either be finite or infinite. Again, that's the idea where we sum it to a certain number n, or we can sum the series to infinity. An infinite series that doesn't have a number n on the top of its summation, it has the infinity symbol. Anybody need more time for that definition? Okay, so for example, if we want to find the sums of these two series, we already know how to do the first one, right? This will be the sum starting at 1 and ending at 3. So it'll be 3 over 10 to the first plus 3 over 10 squared plus 3 over 10 cubed, which is what? Actually, I think it's a little. It's 0.333. Okay. Are you ready for something that messed with the Greeks and the Romans for a long time? The sum of this infinite series is not infinity.
Well, say,
Isn't that crazy?
so crazy.
There is not an infinity sign of the calculator. You have to use your brain to figure out how to do these. You can't use a calculator for us.
At least thought.
I am not. Well, back in the day, they would just say the sum of an infinite number of things is infinity, but it's actually not.
No, it's infinite.
It's not.
How is it not?
Let's do it. You ready?
Go to infinity, Mr. Rick?
I'll do one more. I'll do to the fourth.
That's not infinity. That's not-
And then I'm going to do this. Ready? Dot, dot, dot. Hey, you see that? Okay.
That's the answer.
What is 3 divided by 10?
0.33.
What is 3 divided by 100?
0.3.
Okay. We're going to pretend that you all said the right answer there. What's 3 divided by 1,000?
0.00.
What's 3 divided by 10,000? Okay.
my gosh.
Okay.
Three repeating.
It's 3 repeating.
Wow.
Yep. There.
So does that only work on third?
What a hooligan.
So this is just 0.3 repeating, or 1/3. The sum of that infinite series is 1/3. If you take all those infinite number of things and add them together, you will get the answer 1/3. Isn't that great?
No.
Yes, they all said yes, recording. They all said yes.
I'll let tell Laura to listen to the recording.
Yeah?
Just so she can hear how much you talk to her.
So that is not true for all infinite series. Some infinite series are really infinity. Some will converge to a number. So it's basically divergent or convergent infinite series. If you'd like to hear more, check out my podcast at
Podcast?
no.
I was excited.
You can check out the class Calculus 2. We'll go into all of the math on which series converge, which series diverge, and how to find infinite sums.
Mr. Lynch, start a podcast.
Yeah, do a podcast.
I'd
Yeah?
listen to that. I'd listen to that.
What would the podcast be about?
I don't know, whatever you want to
Just
say.
whatever I want to talk about today? Lake's thoughts of the days.
Yes.
Yeah? It's E. Yes. Oh, so the sum of the infinite series from 1 to infinity of 1 over x factorial is E. That is a convergent series as well.
Can you change my sign calculator?
No, not to that one, because that's somebody else's calculator. I'm pretty sure. What number is that?
What is this?
What number? is it? 8. 8 is you. Or no?
Vanilla is.
Kelsey?
It's like-
Yeah, Kelsey, do you have
Because there's a
this?
lot of those.
Yeah, it's not really. Oh, wait, why does it have it?
Wait,
Because I wasn't using it.
Okay.
Let's the other day, he kept going after the knowledge.
So mine is not a classic word. It's a
But
calculation.
he kept like, why you do this stuff?
Somebody else took it. But you can feel it.
Maybe, I'm an associate. So I wouldn't be.
All right, so I'll put Kendall 45.
Yeah.
Usually it's like 10.
I don't associate.
There's other ones that work too, but yeah, those are the nicer ones. For now.
Oh, average, he's got a computer. What is that like?
Okay. Oh, here's your. Yeah, we'll do this as well work tomorrow. We'll do this as well.
Give me my factory.